Hello, and welcome to Boring Science to Sleep, a quiet place where science becomes slow, soft, and easy to drift through. Tonight, we're going to gently explore why light has a speed limit. Not to learn every equation or uncover every mystery, but simply to notice one of the quietest truths in the universe, one gentle thought at a time. If you truly enjoy these calm journeys through the hidden wonders of science, you're always welcome to like this video and subscribe, only if it feels right for you. And when you're ready, let me know in the comments where you're listening from and what time it is where you are. It's always a quiet joy to imagine people from different corners of the world slowly winding down together beneath the same night sky. Now, dim the lights if you can. Perhaps let a fan hum softly in the background, or simply listen to the quiet sounds already surrounding you. Settle into a comfortable position, loosen your shoulders, relax your jaw, and allow your breathing to become just a little slower than it was a moment ago. There is nowhere you need to be, nothing you need to solve, nothing waiting for your attention. For a little while, the universe can carry those questions for you. Tonight, you are safe. You are warm. You are simply here. It may seem strange that something as familiar as light could still hold one of the deepest secrets in all of science. Every morning it slips quietly through your window. Every evening it fades beyond the horizon, without asking for applause. It paints the colors of flowers, glitters across lakes, reflects from distant clouds, and allows you to recognize the faces of the people you love. It feels so ordinary that it is easy to forget just how extraordinary it really is. Yet hidden inside every gentle beam is an invisible rule that reaches far beyond sunlight. The same quiet rule guides radio signals drifting through space. It guides the tiny pulses of light, carrying conversations beneath the oceans through strands of glass. It guides the clocks aboard satellites high above Earth. It shapes the lives of stars. It bends around galaxies. It even determines how we experience space and time themselves. For generations, scientists have measured this remarkable speed with astonishing precision. They have built telescopes, satellites, computers, and entire theories upon it. And the more carefully they studied light, the more surprising they discovered the universe to be. Because the speed of light is not simply the speed of light. It is something much deeper. It is the universe quietly revealing the rhythm by which everything unfolds. Over the next 2 hours, you won't need to remember names, dates, or complicated ideas. Instead, you'll simply drift alongside a single beam of light as it carries us from a quiet room here on Earth to distant stars, invisible fields, curved space, gentle clocks, ancient galaxies, and finally back home again. Along the way, you may discover that the greatest scientific ideas often feel less like answers and more like peaceful ways of looking at the world. So take one slow breath, and another. Let your thoughts become lighter than they were a few moments ago. As the room grows quieter, and your eyelids perhaps a little heavier, a single gentle question begins to appear. Why does light move the way it does? And why has the universe quietly chosen that one remarkable speed, and no other? Perhaps the answer has been shining softly around you all along. Imagine waking before sunrise, when the world is still wrapped in shades of quiet blue, and everything seems to be waiting. The air feels cooler, sounds travel more softly, and even familiar rooms appear to rest beneath a gentle blanket of darkness. There is no rush here, no urgency, only stillness. Then, almost without noticing, the first light arrives, not with a dramatic entrance, but with patience. A pale glow slowly touches the edge of a curtain. Shadows begin to soften. The outline of a chair quietly returns. The ceiling, which only moments ago disappeared into darkness, gently reveals itself once more. It feels so ordinary that you may have experienced this scene thousands of times without giving it much thought. And perhaps that is one of the greatest gifts of light. The most extraordinary things often become invisible simply because they never stop being present. You have spent every day of your life surrounded by light. It has accompanied every conversation, every walk beneath the trees, every page of every book, every smile you have ever recognized. Even now, as you listen, tiny particles of light may still be bouncing gently around the room before finding their way into your eyes. Without them, the world would not disappear, but your connection to it would become wonderfully, quietly different. It is easy to think of light as something that simply helps us see. In truth, it is constantly carrying little pieces of the universe toward you. Every color you notice, every distant mountain, every cloud floating across the afternoon sky, every familiar face, each arrives because light has quietly gathered information from those places and carried it patiently across space. In a way, light behaves like an endlessly faithful messenger. It never speaks. It never pauses to explain itself. It simply travels, bringing tiny stories from every corner of the world. The warm color of autumn leaves tells you something about the pigments inside them. The blue sky whispers something about Earth's atmosphere. The glowing surface of the moon carries a gentle reminder that its light first began as sunlight before taking another quiet journey toward you. Even the stars overhead are storytellers. Some of the light reaching your eyes tonight may have left its star long before the first cities were built. Some began traveling before ancient civilizations learned to write. Some has crossed distances so vast that the journey itself stretches beyond ordinary imagination. And still, after all that time, those tiny travelers arrive without hurry. Patient, silent, steady. There is something comforting about that. The universe seems to understand that meaningful journeys do not always need to be fast. As you continue listening, you might picture each tiny particle of light as a traveler carrying a small lantern through an unimaginably vast darkness. Not because the universe is truly filled with countless little lanterns, but because gentle images often help us feel ideas that are too large to hold all at once. Every traveler leaves home. Every traveler follows a path. Every traveler eventually reaches someone else. Light has been making journeys like this since long before the Earth was formed, long before oceans covered the planet, long before forests filled the land, long before anyone could ever wonder where light came from. In fact, every atom in your body carries a quiet connection to ancient stars. The elements that make your bones, your muscles, your heartbeat, and even the cells quietly repairing themselves as you rest tonight, were forged deep inside stars that lived and died billions of years ago. Those stars shared their materials with the universe. Light shared their stories. Without light, those stories would remain forever hidden. Scientists often describe light as carrying both energy and information. Those words sound technical, but they describe something beautifully simple. Energy allows light to warm your skin beneath the afternoon sun. Information allows your eyes to recognize the face of someone you love. One brings warmth, the other brings understanding. Together, they quietly shape nearly every moment of your waking life. Yet for something so familiar, light follows an unusual rule, unlike almost anything else we know. You can walk slowly or quickly. Birds fly at different speeds. Clouds drift lazily across the sky. Rivers change their pace as the landscape changes beneath them. Even sound moves differently through air, water, and solid ground. Almost everything around us seems willing to speed up or slow down depending on the circumstances. Light is different. No matter where it begins its journey, no matter how bright or dim it appears, no matter whether it leaves a nearby candle or a distant galaxy, it quietly follows the same remarkable rhythm through the emptiness of space. It is almost as though the universe has whispered one gentle instruction that light has followed faithfully since the beginning of time. Not because it must obey, but because that rhythm is woven into the very fabric of reality itself. That quiet idea may seem almost impossible at first. How could one speed matter to the entire universe? Why would space and time themselves care how quickly light travels? Those questions have patiently waited for curious minds across generations, and little by little, they revealed something even more remarkable than anyone first imagined. Because the story of light is not only about light, it is also the story of space, of time, of gravity, of stars, of every distant galaxy glowing softly across the night. And, in a quiet way, it is also the story of you, sitting here tonight beneath the same ancient light that has been traveling across the universe long before any human being ever looked up and wondered where it had come from. Perhaps that gentle beam arriving through a window tomorrow morning is carrying far more than brightness. Perhaps it is quietly carrying the shape of the universe itself. As that quiet beam of morning light continues its patient journey, another gentle question begins to unfold. What exactly is this familiar companion that has followed every moment of your life? It sounds like such a simple question. After all, light seems almost too ordinary to need an explanation. You switch on a lamp, watch the sunrise, admire the stars, or notice sunlight sparkling on moving water. Light simply appears, as though it has always known exactly what to do. For thousands of years, people believed much the same. Long before telescopes explored distant galaxies, before laboratories filled with polished instruments, and before anyone imagined space bending or time stretching, people simply wondered what light actually was. Some imagined that tiny pieces of light quietly streamed from every object. Others believed that your eyes reached outward, gently touching the world around you. Neither idea sounds quite right today, but they remind us of something comforting. Every generation begins by trying to explain the universe using the language it already knows. As centuries passed, another picture slowly emerged. A Dutch scientist named Christian Huygens imagined light behaving less like countless tiny objects and more like gentle ripples spreading across a peaceful pond. Imagine dropping a single pebble into still water. Perfect circles slowly move outward. Each ripple quietly encourages the next one to continue the journey. No ripple hurries. No ripple needs to know where it is going. It simply carries its motion forward. Huygens wondered whether light might travel in much the same way. It was a beautiful idea. Then another famous scientist, Isaac Newton, looked at light differently. He imagined tiny particles racing through space, each one following a straight path, like grains of fine sand carried gently by the wind. His explanation also made sense. Particles could explain why shadows had such sharp edges. They seemed to travel directly from one place to another without wandering. For many years, these two pictures quietly lived side by side. Was light a wave, or was it made of tiny particles? The universe, as it often does, waited patiently before revealing that the answer was stranger than either idea alone. Generations later, another experiment gently shifted the conversation. Instead of forcing light through one narrow opening, Scientists allowed it to pass through two tiny openings placed side by side. If light were made only of tiny particles, it should have produced two bright bands on the surface behind them. Instead, something much softer appeared. Bright and dark stripes formed together, almost like overlapping ripples meeting upon calm water. The experiment suggested that light could spread, overlap, and quietly interfere with itself, just as gentle waves do. For a long time, that seemed to settle the question. Perhaps light really was a wave after all, and yet the universe still had another quiet surprise waiting. As scientific instruments became more sensitive, researchers discovered moments when light behaved as though it arrived in tiny individual packets, almost like countless miniature visitors arriving one by one. One by one, never in a crowd, never blending together completely. It was as though the ripples upon the pond had somehow become tiny travelers without ever stopping their graceful motion. Modern physics eventually accepted something that first seemed impossible. Light is not simply a particle. It is not simply a wave. It possesses qualities of both. When it travels through space, it can spread gently, like ripples across a quiet lake. When it exchanges energy with matter, it behaves like tiny individual messengers, arriving one at a time. Rather than choosing one identity over the other, light quietly carries both possibilities within its nature. It is one of the reasons the universe remains so endlessly fascinating. The closer we look, the less nature seems interested in fitting neatly inside the categories we invent. Scientists gave those tiny individual messengers a name. They call them photons. You only need to remember the name once. After that, you can simply imagine tiny travelers carrying little pieces of light across the universe. Every sunrise contains countless numbers of these silent travelers. Every star sends them outward in every direction. Every candle releases them into the surrounding darkness. And every moment your eyes remain open, some of them complete their journeys by quietly arriving within your vision. There is another remarkable detail hidden beneath all of this. Unlike sound, light does not need air to carry it. You may have noticed that sound behaves differently. A conversation cannot travel through the empty space between Earth and the Moon. A ringing bell placed inside an empty chamber gradually falls silent because there is less and less air to carry its vibrations. Sound depends upon something physical shaking back and forth. Light does not. Even the emptiness between galaxies does not prevent light from continuing its journey. This puzzled scientists for centuries. What exactly is moving if there is almost nothing there? The answer turned out to be wonderfully elegant. Instead of imagining light as something traveling through space, imagine space itself, quietly participating in the journey. Invisible patterns of electricity and magnetism gently rise and fall together, almost like two dancers taking turns leading one another across an endless floor. As one begins to fade, the other quietly grows stronger. Each encourages the next. Neither ever truly dances alone. Together they move effortlessly through the universe. There is no invisible substance pushing them forward. The dance itself becomes the journey. This quiet partnership creates every kind of light we know. The warm glow from a fireplace, the gentle colors of a rainbow after rain, the invisible signals carrying music to your radio, the quiet connection allowing wireless devices to speak across a room. The gentle warmth you feel from sunlight resting upon your skin. Even the energetic light arriving from distant exploding stars belongs to this same remarkable family. They differ not because they are different kinds of things, but because each dances to its own gentle rhythm. Some dance slowly. Some dance more quickly. Some remain invisible to human eyes. Others become the beautiful colors you have known since childhood. Together they form one enormous family, stretching far beyond anything our eyes alone can see. Perhaps that is one of the most comforting ideas in all of science. The universe is often far more connected than it first appears. The light warming your face, the signal quietly carrying a message across the ocean, and the ancient glow leaving a distant galaxy billions of years ago all belong to the same silent family, following the same quiet rules wherever they travel. And before anyone understood why those rules existed, another question slowly began to emerge. If every member of this great family shares the same remarkable journey through space, how did anyone discover just how fast that journey truly is? If you imagine standing beneath a clear night sky a few hundred years ago, the stars above would have looked almost exactly as they do tonight. The same quiet constellations, the same silver moon, the same gentle river of the Milky Way, stretching softly across the darkness. And yet, although people admired that beautiful sky for thousands of years, one simple question remained almost impossible to answer. How fast does light actually travel? Today the answer feels almost ordinary. Children learn that light moves incredibly quickly. Astronomers use its travel time almost every day. Engineers build technologies that quietly depend upon it. But for most of human history, no one even knew whether light needed time to travel at all. Many thoughtful people believed it arrived instantly. After all, whenever you lit a candle, the room became bright immediately. Whenever lightning flashed across the sky, the world seemed illuminated in a single moment. The delay, if there was one, appeared far too small for human senses to notice. It was a perfectly reasonable belief. Sometimes nature hides its deepest secrets, not because they are complicated, but because they happen far beyond the limits of our everyday experience. One of the first people to wonder seriously about this mystery was Galileo Galilei. Rather than beginning with enormous machines or grand observatories, he started with something wonderfully simple: 2 lanterns. Imagine 2 friends standing on distant hills after sunset. Each carries a covered lantern. The first uncovers the light. As soon as the second person sees it, they uncover their own lantern in return. If light requires time to travel, perhaps a tiny delay could be measured between the 2 signals. It was an elegant idea. Simple, patient, curious. Galileo performed experiments like this with great care. But the light was simply too fast. Before any noticeable delay could be separated from ordinary human reaction time, the tiny travelers had already completed their journey. His experiment did not measure the speed of light, but it quietly revealed something equally important. If light did have a speed, it was astonishingly fast. The question remained. For several more decades, no one knew how to answer it. Then the universe offered help from a place far beyond Earth, far beyond mountains, far beyond oceans, far beyond the clouds themselves. It came from Jupiter. One of Jupiter's small moons, called Io, circles the giant planet over and over again with remarkable regularity. Like the steady ticking of a distant celestial clock, it disappears behind Jupiter, then emerges once more, following a rhythm that hardly changes. A Danish astronomer named Ole Rømer spent years patiently watching this quiet dance, night after night, season after season. He noticed something curious. Sometimes Io appeared slightly later than expected. Other times it appeared a little earlier. At first, this seemed puzzling. Had the moon changed its orbit? Was Jupiter behaving differently? Or was something else quietly influencing the observations? Rømer slowly realized that the answer did not belong to Jupiter at all. It belonged to Earth. As our planet moved around the Sun, the distance between Earth and Jupiter constantly changed. Sometimes Earth was a little closer, sometimes a little farther away. When Earth drifted farther from Jupiter, the light from Io simply had a longer journey to complete. The Moon itself had not changed. The light had. It was one of the most beautiful scientific discoveries ever made. Without touching light, without slowing it down, without catching it, scientists realized they could measure its journey simply by being patient enough to watch the heavens. For the first time, humanity understood that light was not instantaneous. It traveled, even if it traveled incredibly quickly. As the centuries passed, curiosity became more precise. Inventors created ingenious machines that seemed almost like carefully crafted works of art. One scientist designed a rapidly spinning wheel with tiny openings cut around its edge. A beam of light slipped through one opening, raced toward a distant mirror, and returned. If the wheel spun slowly, the returning light found the same opening waiting. If the wheel spun more quickly, another tooth of the wheel quietly blocked the returning beam. By carefully adjusting the wheel's speed, scientists could estimate how long light needed to complete its journey. Another researcher replaced the spinning wheel with a beautifully polished rotating mirror. The mirror turned ever so slightly while the light was away. By measuring the tiny change in the returning beam, the travel time could be estimated even more accurately. These experiments required extraordinary craftsmanship. Tiny imperfections mattered. Small vibrations mattered. Even the quiet stability of the laboratory mattered. Each generation learned to measure a little more carefully than the one before. Then came Albert Michelson. Throughout his career, he devoted himself to measuring the speed of light with astonishing precision. Again and again, he refined the instruments. Again and again, he reduced uncertainty. Each improvement was like polishing an already beautiful piece of glass until it reflected almost perfectly. His work became one of the greatest achievements in experimental science, not because he changed the universe, but because he learned to observe it with remarkable patience. Eventually, the measurements became so reliable that something extraordinary happened. Scientists made a surprising decision. Instead of using distance to measure light, they would use light to define distance. Imagine that for a moment. For thousands of years, people measured light using rulers. Now the ruler itself would quietly depend upon light. It was a profound change in perspective. Rather than asking how fast light travels across a measured distance, humanity chose to let light become the standard by which distance itself is understood. The traveler became the guide. The messenger became the measure. It is a beautiful reminder that science often grows in unexpected ways. Sometimes we begin by observing nature. Then, after centuries of careful listening, nature quietly teaches us how to measure the world more wisely. Perhaps there is another quiet lesson hidden here as well. The people who uncovered these remarkable truths were not chasing excitement. Most of their work consisted of waiting, watching, repeating, questioning, making tiny improvements that almost no one else would notice. Discovery, it seems, is often less like a sudden flash of lightning and more like the slow arrival of dawn. As these increasingly careful measurements settled into agreement, another mystery quietly appeared. Everyone now knew that light traveled at one astonishing speed, but no one yet understood why the universe had chosen that particular rhythm in the first place. Somewhere within the invisible fabric of reality, there seemed to be a deeper answer waiting patiently to be found. Now that people had learned to measure light with extraordinary precision, another quiet mystery slowly came into view. Knowing how fast something travels is one kind of understanding. Knowing why it travels that way is something altogether different. For many years, scientists could only describe what light did. It traveled. It reflected. It bent through glass. It spread into rainbows. It warmed the earth each morning. But no one could explain what light truly was beneath all those familiar experiences. The answer did not arrive all at once. Instead, it emerged little by little, like a landscape becoming visible as morning fog slowly lifts. To begin seeing that landscape, it helps to imagine something you cannot see at all. Imagine placing a small magnet on a wooden table. Nearby lies another magnet. Without touching one another, they quietly pull together, or perhaps they gently push apart. Nothing visible stretches between them. No tiny ropes. No invisible hands. And yet something is clearly happening. Scientists eventually realized that every magnet is surrounded by an invisible region of influence. You cannot see it directly. You cannot hold it in your hands. But its presence quietly reveals itself through the way other objects respond. They called this invisible region a field. The word may sound technical, but the idea is surprisingly gentle. Imagine standing beside a calm lake. You cannot always see the wind itself. Instead, you notice the surface of the water. Tiny ripples appear. The reeds begin to sway. The leaves whisper softly above your head. The wind remains invisible. Its influence does not. A field is much like that. Not an object, not a substance, but a quiet way that nature reaches across space. Magnets create one kind of field. Electric charges create another. For many years, these seemed like two entirely separate stories. Electricity belonged to one chapter. Magnetism belonged to another. They appeared to be distant relatives that happened to live in the same universe. Then, during the 19th century, a remarkable realization slowly unfolded. Scientists discovered that electricity and magnetism were not strangers at all. They were partners. Imagine two dancers moving across a silent stage. One takes a gentle step forward, the other naturally follows. Neither leads forever. Each movement invites another. As one slows, the other quietly rises. Again and again, without beginning or end, they continue their graceful dance. Electricity behaves in much the same way. Whenever an electric field changes, it quietly gives rise to a magnetic field. And whenever a magnetic field changes, it gently creates an electric field. One encourages the other. Then the other responds. Back and forth. Over and over. Neither exists completely alone. At first, this discovery seemed fascinating enough. Two invisible partners, endlessly influencing one another. But then something even more remarkable appeared. Imagine those two dancers standing perfectly still. Nothing happens. Now imagine they begin moving together. One step, then another. The dance itself begins traveling across the stage. In much the same way, changing electric and magnetic fields do not simply remain where they begin. Together, they move outward. The dance itself becomes the traveler. That traveler is what we call light. This was one of the most beautiful ideas ever uncovered in science. Light did not need invisible particles pushing it from behind. It did not need a hidden substance carrying it through space. The changing fields carried one another forward naturally, like an endless conversation that never needed a speaker. One gentle change gave birth to the next, then the next, then the next again, and so the journey continued. Perhaps you can picture it as two friends walking through a quiet forest. One reaches out a hand, the other responds. Then they trade places. Their motion is smooth. Neither pulls the other, neither falls behind. Together they simply continue walking. That peaceful rhythm extends across the universe itself. For the first time, light was no longer just something people observed. It became something they could understand in a deeper way. Not completely. Nature always keeps a little mystery for itself, but enough to reveal that the universe was far more connected than anyone had imagined. The Scottish physicist James Clerk Maxwell gathered these scattered discoveries together with extraordinary patience. Rather than seeing separate ideas, he saw one elegant picture. His work showed that electricity, magnetism, and light all belong to the same quiet family. They were not different phenomena after all. They were different expressions of one deeper pattern. Imagine listening to an orchestra from outside a concert hall. At first, you notice a violin, then perhaps a cello, a flute, a horn. Each seems independent. But once you step inside, you discover they have all been playing the same piece of music. Maxwell experienced something very much like that. Electricity was one instrument. Magnetism was another. Light was the melody they created together. Perhaps the most surprising part of his discovery was what happened next. As Maxwell carefully explored this invisible dance, one particular rhythm appeared naturally. Not because anyone chose it, not because someone measured it first. The universe itself quietly pointed toward one remarkable speed. Long before Einstein transformed our understanding of space and time, long before spacecraft crossed the solar system, and long before lasers carried information beneath the oceans, the mathematics quietly hinted that this dance should move at exactly one universal pace. The astonishing part was that this predicted pace matched the measured speed of light. It was not merely close, it was the same. Suddenly, everything fit together. Light was not racing through the universe by coincidence. Its speed emerged naturally from the very relationship between electricity, magnetism, and the fabric of empty space. The speed was not something added afterward. It had been woven into the story from the very beginning. This changed the meaning of empty space itself. For centuries, people imagined a vacuum as perfect nothingness, a place where absolutely nothing existed. No air, no dust, no sound. Nothing at all. Modern physics paints a gentler picture. Even when space appears completely empty, it still possesses quiet properties of its own. Not objects, not hidden clouds, but rules, relationships, possibilities, the invisible stage upon which the dance of light can unfold. In that sense, space is not an empty box waiting to be filled. It is more like a silent ocean whose calm surface allows gentle waves to travel without ever becoming visible itself. You cannot scoop this ocean into a bucket. You cannot watch it shimmer beneath sunlight. Yet every beam of light depends upon its quiet presence. Perhaps that is why the universe often feels so beautifully simple once its deeper patterns begin to appear. Instead of countless unrelated mysteries, many separate questions slowly become one connected story. Electricity becomes magnetism. Magnetism becomes light. Light reveals space. And space quietly prepares us for an even more surprising discovery. Because if the speed of light belongs to the very structure of the universe itself, then perhaps it is not light that must adapt to space and time. Perhaps it is space and time that quietly adapt to light. If you picture the universe as an endless, quiet ocean, then light might seem like one of its countless travelers. Some travelers leave nearby stars. Others begin their journeys inside distant galaxies. Some emerge from a candle beside your bed. Others have been traveling since long before our own sun was born. Their journeys begin in different places. They carry different colors. Some are visible. Many remain forever invisible to human eyes, and yet when they move through the emptiness between stars, they all share one remarkable habit. They travel with the same quiet rhythm. It almost feels impossible. Imagine watching birds crossing the sky. Some glide slowly. Others flap their wings with great determination. A gentle breeze may help one bird while slowing another. Now imagine rivers. Some rush through narrow valleys. Others wander lazily across peaceful plains. Everything around us seems willing to change its pace depending upon its surroundings. Even you do. There are mornings when your steps feel light and energetic. There are evenings when every movement naturally becomes slower. Almost nothing in everyday life insists upon moving at one perfectly fixed speed. Light is different. Whether it comes from a tiny candle, a distant star, or a powerful laser built inside a laboratory, once it begins traveling through empty space, its journey unfolds with the same extraordinary consistency. For centuries, this seemed almost unbelievable. Surely something could make light travel a little faster, or perhaps a little slower. Surely brighter light might move differently from dim light, or blue light from red light. These all sound like reasonable guesses. Nature, however, quietly chose another path. Brightness changes, color changes, energy changes, but the journey itself remains wonderfully faithful. It is rather like listening to an orchestra. Some instruments play softly, others play loudly. Some notes sound deep, others seem bright and delicate. Yet the rhythm holding the entire performance together remains unchanged. Every musician follows the same quiet beat. Light behaves in a surprisingly similar way. Its many colors and forms resemble different instruments, while the universal speed limit quietly keeps the entire performance in harmony. This naturally leads to another question. Why? Why should the universe care? Why should every beam of light, no matter where it begins, quietly agree upon the same remarkable pace? One possible answer might seem obvious at first. Perhaps light itself possesses some hidden property, forcing it to travel this way. That sounds sensible. But it turns out to be only part of the story. Imagine two people walking across different landscapes. One crosses soft sand. The other walks along smooth stone. Even if both try to move in exactly the same way, the ground beneath them influences every step. Now imagine replacing the ground itself, not with another surface, but with the invisible stage upon which every journey takes place. That stage is space itself. The deeper scientists looked, the more they realized that light was not carrying its speed inside itself like a secret treasure. Instead, space quietly offered only one natural rhythm for light to follow. It was rather like water, allowing gentle waves to spread across its surface. The waves are free to travel, but the water quietly determines how that journey unfolds. In this sense, the speed limit belongs less to light and more to the universe itself. This is one of those ideas that initially feels backwards. We often imagine objects deciding how they move. Instead, nature suggests something gentler. The universe provides the rhythm. Light simply follows it. There is another beautiful clue hidden inside the smallest travelers of light. Earlier, we imagined these tiny messengers carrying little stories across the cosmos. Scientists call them photons, but you can simply continue imagining quiet travelers if that image feels more peaceful. Unlike almost everything else we know, these travelers never stop to rest. Not because they are impatient, not because they refuse, but because resting simply does not belong to their nature. Imagine asking a ripple upon a pond to become completely still while remaining a ripple. The request itself no longer makes sense. Once the ripple becomes perfectly still, it is no longer a ripple at all. Something similar is true for light. If a photon could somehow stop moving through empty space, it would no longer be the kind of traveler that nature created. Its journey and its identity belong together. This idea surprised physicists for many years. Almost everything in your everyday experience can pause. A bird lands. A train reaches the station. The wind eventually becomes calm. Even rivers may freeze beneath winter skies. Light alone seems to know only one way of existing. Always traveling, always carrying, always connecting one place with another. This also explains another remarkable thought. You can imagine yourself standing beside a parked bicycle, or sitting quietly inside a motionless boat, or resting beneath a tree. There is always some place where you can say, "Here I am." For light, there is no such resting place, no peaceful chair, no quiet harbor, no final destination where the journey stops while the traveler remains. Existing as light means existing in motion. It is one continuous story. Mathematicians describe this idea with careful language, but for our quiet journey tonight, perhaps it is enough simply to picture an endless traveler who never needs to unpack a suitcase because the road itself is home. The more scientists reflected upon these ideas, the more extraordinary the universe appeared. The universal speed limit was not merely preventing things from moving faster, it was quietly stitching together everything that happens: stars, galaxies, planets, atoms. Even the thoughts forming gently inside your own mind depend, in one way or another, upon light faithfully following the same invisible rhythm. Without that shared rhythm, every corner of reality would begin telling a different story. Signals might arrive before they were sent. Events might lose their natural order. The quiet harmony of the universe would slowly begin to unravel. Instead, nature chose consistency, one steady pace, one silent promise, one invisible rhythm stretching from the smallest particles to the largest clusters of galaxies. Perhaps this is why light feels so comforting. Not because it is fast, but because it is dependable. Every sunrise arrives through the same quiet laws that guided the first stars. Every beam entering your room tomorrow morning will follow exactly the same gentle rhythm that distant galaxies obey tonight. The universe does not ask light to invent a new path each morning. It simply invites it to continue the journey it has always known. And somewhere within that remarkable consistency, a young patent clerk in Switzerland would eventually begin asking an even stranger question. What if this universal speed never changes? Not because light behaves strangely, but because space and time themselves quietly reshape around it. There are moments in the history of science that arrive with great fanfare. A rocket leaves the ground. A telescope captures a breathtaking image. A spacecraft touches the surface of another world. And then there are discoveries that begin in almost complete silence. No explosion, no cheering crowd, only a quiet room, a thoughtful mind, and a simple question that refuses to disappear. Near the beginning of the 20th century, a young man named Albert Einstein spent much of his time working in a patent office in Switzerland. His daily work was not filled with giant laboratories or towering telescopes. Instead, he carefully examined inventions submitted by other people, reading descriptions of clocks, machines, electrical devices, and countless clever ideas. It was patient work, careful work, the kind of work that quietly teaches someone to notice details. Yet while he reviewed these inventions during the day, another invention was slowly taking shape inside his imagination. Not a machine, not a tool, but an entirely new way of seeing the universe. Einstein loved thought experiments. Instead of building complicated equipment, he often built quiet little worlds inside his mind. He would imagine impossible situations, then patiently follow them wherever they wished to go. One particular question stayed with him for many years. Imagine, he wondered, that you could somehow run alongside a beam of light, not for a moment, not merely watching it, but matching its speed perfectly, as though you and the light were traveling together across the universe. What would you see? At first, the question feels almost playful, like something a curious child might ask while lying beneath the stars. But the more Einstein considered it, the stranger it became. If you could keep pace with a beam of light, would it appear frozen beside you? Would its gentle waves stop moving altogether? Would the universe allow such a thing? The deeper he explored the idea, the more uncomfortable the answers became. Everything scientists already knew about light suggested that this could never happen. Light was not something that could simply pause. Its very nature depended upon movement. A frozen beam of light did not seem to make sense at all. It was rather like imagining a melody that no longer unfolds through time while somehow remaining music, or a ripple that has completely stopped moving while still remaining a ripple. The picture quietly fell apart. Einstein realized that something else had to change. Perhaps the problem was not with light. Perhaps the problem was with the way people imagine space and time. For centuries, most people had quietly assumed that space and time behaved like an enormous stage. The stage never changed. Events happened upon it. People walked across it. Planets moved through it. Stars drifted within it. But the stage itself remained perfectly still. Imagine an old theater. Actors come and go. Scenes change. Music begins and ends. Yet the wooden floor beneath them never stretches or shrinks, simply because the play has changed. That was how many people imagined the universe. Space was the floor. Time was the clock hanging on the wall. Steady, reliable, the same for everyone. Einstein gently questioned that picture. What if the stage itself was not fixed? What if the floor could quietly stretch? What if the clock could gently change its rhythm? Not because they were broken, not because anyone touched them, but because that was simply how the universe preserved its deeper harmony. Imagine two friends taking a long train journey across a peaceful countryside. One friend remains comfortably seated inside the train. The other watches from a quiet station as the train glides past. Both are honest observers. Both pay careful attention, yet their experiences naturally differ. The passenger sees the countryside moving. The observer on the platform sees the train moving instead. Neither person is mistaken. Each simply describes the journey from a different place. This idea was already familiar long before Einstein. Motion often depends upon perspective. But Einstein noticed something remarkable. What if light refused to behave this way? What if every observer, no matter how they were moving, always measured exactly the same speed for light? At first, this sounds impossible. Surely someone chasing a beam of light should measure it moving more slowly. Surely someone traveling toward the beam should measure it moving more quickly. That is exactly what everyday experience teaches us. If you walk toward falling rain, the drops seem to meet you more quickly. If you run after a rolling ball, it becomes easier to catch because the distance between you changes more slowly. Almost everything behaves this way. Light does not. Every careful experiment pointed toward the same extraordinary conclusion. No matter who measured it, no matter where they traveled, no matter how quickly they moved, light always followed the same quiet rhythm. Nature was telling scientists something profoundly important. Not about light, about reality itself. If everyone agrees on the speed of light, then something else must quietly adjust instead. Space quietly changes. Time quietly changes. The speed of light does not. This was one of the boldest ideas ever proposed. It did not ask people to abandon everything they knew. Instead, it invited them to let go of one deeply familiar assumption. Perhaps space was not perfectly rigid. Perhaps time was not flowing identically everywhere. Perhaps they were more like soft fabric than solid stone. Imagine holding a beautifully woven blanket. Lay it flat across a bed, and its pattern appears calm and regular. Now gently pull one corner. The threads do not break, they simply shift together. The pattern changes while the blanket remains whole. Einstein began to picture reality in a surprisingly similar way. Space and time were not separate things. They belonged together, woven into one continuous fabric. Most of the time, this fabric feels wonderfully ordinary. You wake, you eat breakfast, you walk through familiar streets. Hours pass with comforting regularity. Nothing seems unusual. Yet beneath those ordinary moments, the fabric quietly responds to motion in ways far too gentle for everyday life to reveal. Only when speeds become unimaginably great does its flexibility begin to show itself. It does not tear. It does not ripple dramatically. It simply adjusts, quietly, patiently, almost invisibly, like silk settling beneath the weight of a single falling feather. This beautiful picture solved Einstein's original question. You can never travel alongside a frozen beam of light, because the universe will quietly reshape space and time before allowing such a situation to exist. It does not force light to change. Instead, it gently changes the stage upon which every journey unfolds. That single realization transformed physics forever. Not because it made the universe stranger, but because it revealed that reality had been far more graceful all along than anyone had imagined. And once space and time became free to bend gently around motion, another remarkable discovery quietly followed. Clocks themselves might no longer keep exactly the same rhythm for everyone. Imagine placing two beautiful clocks side by side upon a quiet wooden table. Both are carefully built. Both begin ticking at exactly the same moment. Both seem perfectly synchronized, each gentle tick following the next with comforting certainty. Now imagine that one clock remains peacefully where it is, while the other begins an extraordinary journey, not hurriedly, not racing through crowded streets. Instead, imagine it drifting smoothly through the darkness of space, carried by a spacecraft moving faster than anything human beings have ever built. Days pass, then months. Eventually, the traveling clock returns home. You place the two clocks beside one another once again. At first glance, they appear exactly the same. The polished hands, the smooth glass, the quiet rhythm. And yet, something almost impossible has happened. They no longer agree. One has measured ever so slightly less time than the other. Not because either clock was damaged, not because one was poorly made, but because the universe quietly allowed time itself to unfold differently along each journey. For generations, this idea felt almost unimaginable. Time seemed like the one thing everyone should always share. Morning followed night. Spring followed winter. Children became adults. The moon quietly circled Earth. Everything appeared to move together beneath one great cosmic clock. It was a comforting picture, simple, steady, reliable. But nature, as we have slowly discovered, often prefers gentle elegance over simple certainty. Einstein realized that once the speed of light remains the same for everyone, something else must quietly adjust. In our previous journey, we imagine space and time as threads woven together into one soft fabric. Now we begin to notice that this fabric is not completely rigid. It possesses a quiet flexibility, not enough for us to notice while strolling through a peaceful garden or preparing a cup of tea, but enough to reveal itself when motion becomes extraordinarily fast. Perhaps another image feels even gentler. Imagine two musicians sitting together at a piano. At first, they play in perfect harmony. Each note arrives exactly when expected. Then one musician slowly walks farther away while continuing to play. You still hear the melody. The rhythm still exists. Yet somehow the experience begins to feel slightly different. Not wrong, simply different. Time behaves in a similarly quiet way. It never stops. It never breaks. It simply allows different journeys to carry slightly different rhythms. This remarkable idea has become known as time dilation. The name sounds technical, but the experience it describes is surprisingly gentle. You can think of it simply as clocks, quietly keeping different rhythms after traveling along different paths through the universe. One of the most famous stories used to explain this idea involves twins. Imagine two brothers, or perhaps two sisters, who begin life together. They celebrate birthdays on the same day. They laugh together as children. They grow up beneath the same sky. One eventually remains on Earth, living an ordinary life filled with familiar mornings, changing seasons, quiet conversations, and peaceful evenings. The other departs on an extraordinary journey aboard a spacecraft traveling at an astonishing speed. Years later, the traveler returns. Both have lived every moment of their own lives naturally. Neither felt that time suddenly sped up. Neither noticed clocks behaving strangely. Each day seemed perfectly ordinary from their own perspective. Yet when they stand together again, the traveler has experienced slightly less time. Not because anyone stole those years, not because life paused, simply because the universe measured their journeys differently. It is one of those rare ideas that sounds almost like poetry before it becomes science. Different paths through the universe quietly carry different amounts of time. Fortunately, you do not need to travel among the stars to know that this idea is real. The universe has already provided smaller examples much closer to home. Far above Earth, satellites circle our planet every day. Most people rarely think about them. They quietly move across the sky while we prepare breakfast, drive to work, or fall asleep at night. They ask for no attention. Yet hidden inside each satellite are extraordinarily accurate clocks. These are among the finest clocks humanity has ever built. They are so precise that they lose or gain only tiny fractions of a second over enormous periods of time. When scientists compared these clocks with matching clocks remaining on Earth, they discovered something remarkable. They did not remain perfectly synchronized. Exactly as Einstein predicted, the moving clocks experience time just a little differently. The difference is astonishingly small, far too small for anyone to notice during an ordinary day. Yet modern instruments are patient enough to detect even such tiny changes. Those tiny differences matter. Every day, navigation satellites quietly adjust their clocks. Without those gentle corrections, the maps inside your phone would slowly become less accurate. Roads would appear slightly misplaced. Ships would drift from their intended positions. Airplanes would gradually lose precision. The technology itself is impressive, but perhaps even more beautiful is what it quietly reveals. Every time you ask your phone for directions, you are benefiting from Einstein's quiet insight about time. Not because your phone performs dramatic miracles, simply because engineers have learned to listen carefully to the gentle rhythm of the universe. The clocks inside laboratories tell a similar story. Scientists have compared clocks carried aboard airplanes with identical clocks left safely on the ground. After the journeys ended, the clocks no longer agreed perfectly, only by unimaginably tiny amounts, but enough to show that time had faithfully followed Einstein's prediction. These experiments were not trying to make time mysterious. They were simply listening carefully enough to notice what had always been true. Perhaps that is one of the most comforting lessons in science. Nature rarely changes because we discover it. Instead, our understanding slowly grows quiet enough to hear what the universe has been whispering all along. Time was never broken. It was never inconsistent. It has always followed the deepest structure of reality with extraordinary faithfulness. We simply needed better questions, better clocks, and enough patience to notice the answers. As beautiful as this discovery is, it also invites another quiet question. If motion can gently change the rhythm of time, might it also change the shape of space itself? That possibility, surprising though it may seem, is waiting just beyond the next gentle step of our journey. Imagine standing beside a long railway track on a calm afternoon. The air is still. A gentle breeze moves through the nearby trees. Somewhere in the distance, a train slowly appears, growing larger as it glides toward you. There is nothing unusual about the scene. You have probably watched trains many times before. They arrive, they pass, they disappear beyond the horizon. Everything feels wonderfully ordinary. Now imagine something slightly different. Instead of standing beside the tracks, you are comfortably sitting inside the train itself. Outside your window, fields drift quietly past. Clouds float above distant hills. The steady rhythm of the wheels becomes almost soothing. The journey feels peaceful. Neither view is wrong. One person watches the train move through the landscape. The other watches the landscape move past the train. Both descriptions are equally honest. Both are equally real. Long before Einstein, scientists already understood this much. Motion depends upon where you happen to be. But Einstein gently asked another question. If two people moving differently, both measure the same speed of light, what else must quietly change to make that possible? We have already discovered that time can adjust its rhythm. Now another quiet surprise begins to appear. Space itself can also gently adapt. At first, this sounds almost impossible. After all, a wooden table seems to have the same length whether you measure it today or tomorrow. A bridge does not appear to shrink because someone walks across it. The room around you feels reassuringly steady. And for the gentle speeds of everyday life, it truly is. The changes Einstein described are far too small for ordinary experience to reveal. Yet, when motion becomes unimaginably fast, the universe quietly behaves in a different way. Imagine holding a long ribbon between your hands. The ribbon is soft, flexible, gentle. If you pull it carefully, its shape changes ever so slightly. It remains the same ribbon. Nothing has been damaged. It has simply responded to the way you hold it. Space behaves in a surprisingly similar manner, not because someone stretches it with their hands, but because motion quietly changes the way different observers measure distance. Scientists call this idea length contraction. The name sounds mechanical. Perhaps a gentler image serves us better. Imagine reading a familiar book from directly in front of you. Every page appears perfectly clear. Now slowly turn the book sideways. The pages have not changed, yet from your new angle, they seem thinner. The book itself remains exactly what it has always been. Only your perspective has changed. Length contraction is not exactly like this, but the feeling is surprisingly similar. The universe quietly allows different observers to describe distance in slightly different ways without either observer being mistaken. Objects do not suddenly crumple. They do not become compressed like folded paper. Instead, the measurements themselves gently depend upon motion. It is another reminder that reality is often softer than our first impressions. Space is not a rigid ruler carved from stone. It is part of the same flexible fabric we encountered earlier. Time adjusts, space adjusts. Together they quietly preserve the universe's deeper harmony. This harmony becomes even more beautiful when we begin thinking about a word we use every day without much hesitation. Now, it seems like one of the simplest words imaginable. Right now, this very moment. Surely everyone everywhere shares the same present. Or so it appears. Imagine two friends standing several kilometers apart beneath a peaceful evening sky. One stands beside a quiet lake. The other waits upon a gentle hill. Far above them, clouds drift silently beneath the fading light. At exactly what seems to be the same moment, two distant flashes of lightning brighten the horizon. One appears beyond the lake, the other beyond the hills. A person standing halfway between the two flashes sees both bursts of light arrive together. It feels perfectly natural to conclude that both flashes happened at the same time. Now imagine another observer traveling smoothly past the scene aboard a very fast train. This traveler is moving toward one flash while gently moving away from the other. The light from one flash has a slightly shorter journey to complete. The other must travel just a little farther. Remember something we have already discovered. Every observer measures light traveling with the same faithful rhythm. Nature does not allow one beam to hurry while another slows down. Instead, each observer quietly builds a different understanding of when the two flashes occurred. Neither observer is careless. Neither has made a mistake. They simply experience the same universe from different journeys through space and time. Scientists call this remarkable idea the relativity of simultaneity. It is certainly one of the longest phrases in our journey tonight. Fortunately, the idea itself is much gentler than the name suggests. You can simply think of it this way. The universe does not carry one enormous clock that everyone reads together. Instead, each journey quietly weaves its own pattern through the fabric of reality. Most of the time, these patterns agree so closely that we never notice any difference. Life proceeds exactly as we expect. Breakfast follows sunrise. Evening follows afternoon. Friends meet at familiar places. Conversations begin and end naturally. The universe remains wonderfully dependable. Only when motion becomes extraordinarily great do these hidden differences slowly emerge. Perhaps another image helps gather everything together. Imagine an enormous woven tapestry stretching far beyond anything you can see. Each thread represents a journey. Some threads travel almost side by side. Others gradually separate. Still others gently cross before continuing onward. No single thread tells the whole story. Only together do they create the complete pattern. Space and time resemble that tapestry. Every observer follows a different thread. Every journey contributes another beautiful line to the larger design. No perspective is privileged above all others. The universe quietly welcomes them all. It is a surprisingly peaceful idea. Reality does not insist that everyone stand in exactly the same place. It simply asks that each observer listen carefully from wherever they happen to be. And once we accept that space can gently change its measurements, and that moments we call now may not be shared quite as universally as we once imagined, another profound question naturally begins to appear. If both space and time quietly reshape themselves to preserve the universe's deepest rhythm, what happens when something tries to travel even faster than that rhythm allows? By now, the universe has quietly revealed something remarkable. Time is not completely fixed. Space is not completely fixed. Both gently adapt themselves to preserve one invisible rhythm that light follows with perfect faithfulness. Naturally, another question begins to appear. If light moves at this extraordinary speed, why can't everything else do the same? It seems like such a human question. Whenever we discover a record, we immediately wonder whether it can be broken. The tallest mountain, the deepest ocean, the fastest runner, the longest flight. Again and again, history tells stories of limits that eventually gave way to new possibilities. So it feels almost natural to ask whether one day we might simply build a faster spacecraft, one that travels beyond light itself. Nature's answer is surprisingly gentle. It is not a loud no. Instead, it quietly reshapes the question. Imagine walking along a peaceful path. At first, every step feels effortless. You barely notice the movement. Then the path begins climbing a gentle hill. Each step asks for a little more effort. The higher you climb, the more your body quietly reminds you that every extra meter requires just a little more energy. Eventually, the hill becomes so steep that every additional step feels noticeably harder than the one before. Now imagine a hill that never truly ends. No matter how far you climb, it always becomes steeper. Every new step asks for more effort than the last. You never encounter a wall. No gate blocks your way. The journey simply becomes more and more demanding without limit. This is surprisingly close to how motion behaves as objects approach the universe's shared speed limit. At the gentle speeds of everyday life, making something move a little faster is usually straightforward. Push a bicycle. The bicycle speeds up. A stronger push sends it moving a little faster still. The same seems true for a car, an airplane, or even a spacecraft. More energy, more speed. The relationship feels comfortably familiar. But as an object moves faster and faster, something subtle begins to happen. Each additional increase in speed asks for a little more energy than the one before, then a little more, then considerably more. The closer the object comes to the speed followed by light, the more dramatic this pattern becomes. Nature does not suddenly build a wall. Instead, it quietly stretches the hill until its slope seems to rise forever. To reach the speed of light completely, the required energy would continue growing without ever finding an end. It is like trying to fill a cup that quietly becomes larger every time another drop is poured inside. The closer you come to filling it, the larger it becomes. Not because someone is preventing you, simply because that is how the cup has been made. The universe behaves with the same quiet elegance. It does not forbid the journey through force. It shapes the journey through its own deep structure. This naturally leads to another gentle question. If everything else finds the hill endlessly steep, why does light travel there so effortlessly? The answer begins with one important difference. Most of the objects we know possess mass. A pebble has mass, a tree has mass, the moon has mass. Your own body, quietly resting where you are now, has mass. Mass gives objects a kind of gentle resistance to changes in motion. It is not a burden. It is simply one of the ways nature describes matter. Light is different. Its tiny travelers, the photons we met earlier, do not possess this kind of resting mass. Imagine two travelers preparing for a long journey. One carries several heavy suitcases. The other carries nothing at all. Neither traveler is stronger or weaker. Their journeys are simply different. The traveler carrying luggage naturally requires more effort to climb each hill. The traveler carrying nothing moves freely from the very beginning. The image is not perfect, but it gently captures the spirit of the idea. Photons do not need to climb the endless hill. They begin their existence already following the quiet rhythm built into the universe. That rhythm is simply where they belong. Earlier, we imagined that photons never stop to rest. Now we can understand that picture a little more deeply. It is not that photons refuse to slow down. It is that the universe has never given them another way to exist. A bird may perch upon a branch. A boat may rest in a quiet harbor. A train eventually reaches its station. But light knows no peaceful station waiting at the end of its journey. Its existence and its motion are woven together. One cannot be separated from the other. There is another idea hidden inside this picture, one so surprising that it almost feels like a whisper from the universe itself. Mathematicians have discovered that, from the photon's own perspective, something extraordinary happens. Or perhaps more accurately, from the perspective that the mathematics gently points toward. Imagine a photon leaving the warm surface of the sun. It begins an incredible journey across space before finally arriving here on Earth. From our perspective, that voyage takes a little more than 8 minutes. Enough time to brew a cup of tea. Enough time for clouds to drift gently across the sky. Enough time for someone to finish a quiet conversation. For us, those minutes are very real. But within the mathematics of relativity, something astonishing appears. For the photon itself, no time passes during the journey. Its departure and its arrival belong to one continuous moment. This is not because the photon owns a magical clock that runs differently. In fact, physicists are careful to point out that light does not possess a normal frame of rest like you or I do. So we should not imagine the photon consciously experiencing anything at all. Still, the mathematics offers a beautiful image. The sunlight warming your face this morning left the sun more than 8 minutes earlier. Yet the journey itself contains no passage of time for the light along the way. The universe quietly joins beginning and ending with astonishing elegance. Perhaps this helps explain why light feels so timeless. The same ancient starlight that has crossed unimaginable distances reaches your eyes tonight without ever appearing tired, without growing old, without slowing its faithful rhythm. It simply arrives, patiently, silently, exactly as the universe has always asked it to. And because nothing carrying information can travel beyond this shared rhythm, another beautiful consequence quietly emerges. The universe gains something even more precious than speed. It gains order. Imagine dropping a single pebble into the middle of a perfectly still pond. For one quiet moment, nothing seems to happen. Then tiny circles begin spreading gently across the surface. Each ripple moves outward with calm determination. It does not leap instantly to the far shore. It does not appear everywhere at once. Instead, it patiently visits one place after another. First the water nearby, then the reeds growing along the edge, finally the distant bank. Every part of the journey unfolds in its own quiet moment. There is something deeply comforting about that. The ripples never become confused about where they have been. The shore is never disturbed before the pebble touches the water. The story unfolds in a gentle and dependable order. First comes the cause, then comes the effect. We rarely stop to think about how remarkable this is. Strike a piano key. Only afterward do you hear the note. Light a candle. Only afterward does the room begin to glow. Wave to a friend across a field. Only afterward do they smile and wave back. Your entire life is built upon this quiet sequence, one moment gently giving rise to the next, It feels so natural that it almost disappears from our attention. Yet hidden beneath every ordinary experience is one of the deepest rules the universe has ever written. Information needs time to travel. Nothing announces itself everywhere all at once. Every message, every signal, every whisper of light begins somewhere before it quietly arrives somewhere else. Earlier in our journey, we discovered that light faithfully follows the same remarkable rhythm throughout the universe. At first, that sounded like a fascinating property of light itself. Now we begin to see something even more profound. That same rhythm quietly organizes reality. Imagine standing alone in a wide-open meadow beneath a peaceful evening sky. The grass moves gently in the breeze. Above you, the first stars begin appearing one by one. You clap your hands once. The sound spreads outward through the air. If someone is standing nearby, they hear the clap almost immediately. Someone farther away hears it a little later. Someone standing beyond a distant hill may not hear it at all. The important detail is not how fast the sound travels. The important detail is that the message spreads outward gradually. Now imagine replacing sound with light. Instead of a clap, imagine switching on a small lantern in the darkness. The light also begins a journey. It quietly expands outward, carrying news that something has happened. Nearby places learn first. Farther places learn later. The universe does not deliver every message simultaneously. It patiently allows each event to share its story one quiet step at a time. Physicists have a beautiful way of picturing this invisible pattern. They imagine every event surrounded by an expanding boundary, growing outward at the speed of light. The formal name for this picture is a light cone. It is a useful name, but tonight perhaps we can imagine something gentler. Picture yourself holding a lantern in the middle of an endless field on a perfectly dark night. The instant you uncover the flame, light begins spreading in every direction. Not infinitely, not everywhere at once. Simply outward, steadily, patiently. Every place the light has already reached now knows that the lantern exists. Every place beyond that growing boundary has not yet received the message. The expanding glow becomes an invisible frontier between what can already be connected and what must still wait. You can think of this growing frontier as one of the universe's quiet boundaries. Not a wall, not a fence, simply the natural edge of how quickly information can travel. Everything inside that boundary may influence one another. Everything beyond it must wait a little longer. This invisible structure quietly surrounds every event that has ever happened, every heartbeat, every sunrise, every supernova, every falling leaf, every conversation. Each begins by sending gentle messages outward into the universe. Some messages reach nearby places quickly. Others continue traveling for millions or even billions of years. Many are still traveling tonight. Perhaps this helps explain why astronomers often describe the universe as a conversation taking place across enormous distances. The stars are speaking. Galaxies are speaking. Even the faint glow left behind from the early universe continues carrying its ancient message. The conversation is simply very slow. The universe never rushes. At first, you might wonder why any of this matters. Why should nature care whether information arrives instantly or gradually? Imagine, for just a moment, a universe without this quiet order. Imagine hearing an echo before anyone speaks. Imagine receiving tomorrow's sunrise before tonight's sunset. Imagine reading the last page of every story before the first page has even been written. The world would become deeply confusing, not mysterious, simply impossible to understand. Cause and effect would lose their gentle rhythm. Nothing could be trusted to happen in a meaningful sequence. The universe would no longer tell stories. It would become a collection of disconnected moments. Instead, nature quietly chooses patience. Every event waits its turn. Every message travels honestly. Every consequence follows its cause. The universe protects this beautiful order with extraordinary consistency. Perhaps that is why the speed limit exists at all. It is tempting to think of it as a restriction, a rule preventing us from going faster. But perhaps the opposite is true. Perhaps it is a gift. Imagine walking along a peaceful mountain trail. Beside the path stands a simple wooden railing. The railing is not there to spoil the view. It is there to quietly keep the journey safe. Most of the time, you hardly notice it. Only when the path becomes steep do you appreciate its quiet presence. The universe's speed limit feels much the same. It is less like a prison, and more like a safety rail stretching across reality itself. It quietly protects the order of every conversation, every sunrise, every orbit, every heartbeat, every memory, and every distant beam of starlight. Without it, the universe would lose the gentle rhythm that allows one moment to blossom naturally into the next. Perhaps that is one of the deepest lessons hidden inside light. Its remarkable speed is not simply about moving quickly. It is about allowing the universe to remain understandable, to remain dependable, to remain a place where stories can unfold, one peaceful page after another. And once we begin to trust that quiet rhythm, another beautiful realization naturally follows. Every time you look across the night sky, you are not only looking across unimaginable distances, you are also looking gently backward through time itself. If you step outside on a clear evening and lift your eyes toward the stars, it may feel as though the entire universe is sharing one single moment with you. The moon hangs quietly above the trees. Bright stars shimmer softly against the darkness. A faint band of the Milky Way stretches across the sky like a river of pale silver. Everything seems wonderfully present, wonderfully immediate, as though the whole universe exists together in one peaceful night. And yet, one of the gentlest discoveries in astronomy tells a different story. The light reaching your eyes tonight did not all begin its journey at the same time. Some of it left only a little while ago. Some has been traveling for years. Some has crossed thousands, millions, or even billions of years before quietly arriving here. The night sky is not a single moment. It is a collection of many different moments, patiently gathered together above your head. Earlier, we discovered that light never arrives instantly. Every message needs time to travel. That simple idea now begins to unfold into something far more beautiful. Imagine receiving a handwritten letter from an old friend. You carefully unfold the paper. The words may bring laughter. Perhaps they bring comfort. Perhaps they remind you of a memory long forgotten. Yet as you read, you understand something quietly important. The letter is not describing the present, it is describing the moment when it was written. Your friend may already be somewhere else. The weather may have changed. The flowers mentioned in the letter may have finished blooming weeks ago. The letter is a small window into another time. Light behaves in much the same way. Every beam arriving from the universe carries a message that began long before it reached you. The sunlight warming your face each morning began its journey more than 8 minutes earlier. When you watch the sun rise above the horizon, you are seeing the sun as it was several minutes ago. The difference is so small that everyday life hardly notices. The universe quietly hides the delay beneath the ordinary rhythm of morning. The moon tells a slightly older story. Its reflected light takes just over a second to reach Earth. If you wave toward the moon, the light carrying that gesture will begin its own quiet journey outward. Long after your arm has returned to your side, the message continues traveling. The planets tell older stories still. Light arriving from Jupiter has been traveling for many minutes. From the distant planets near the edge of our solar system, the journey becomes much longer. Every object in space quietly speaks from a different chapter of time. Then the stars begin their stories. The nearest star beyond our own sun is so distant that its light spends several years crossing the darkness before reaching Earth. Imagine that for a moment. The gentle point of light you notice above the trees tonight began its journey years before this evening ever arrived, before today's sunrise, before last winter, before many ordinary moments that now exist only in memory. That tiny beam has been traveling patiently all this time. Farther away, entire clusters of stars whisper from even older chapters. Some of the glowing clouds scattered across the galaxy began sending their light while your grandparents were still children. Some galaxies visible through powerful telescopes began their journeys long before human civilization built its first cities. The farther we look, the older the stories become. Distance quietly transforms into history. This is one of the most peaceful ideas in astronomy. Looking farther does not simply mean looking across greater distances. It also means looking deeper into time. Every telescope becomes something far more wonderful than a machine that makes distant objects appear larger. It becomes a quiet time machine, not the kind imagined in adventurous stories. Not a machine carrying travelers backward through history. Instead, it patiently gathers ancient light that has already been traveling toward us all along. Astronomers do not force the universe to reveal its past. They simply wait for its oldest messages to arrive. Imagine standing beside a calm river. Tiny leaves float gently downstream. Some passed by only moments ago. Others have been traveling much longer. You do not need to chase them. You simply watch them arrive. Light behaves very much like those quiet leaves. The universe has been sending messages in every direction since the earliest chapters of its history. Earth simply happens to meet some of those travelers tonight. As telescopes became larger and more sensitive, humanity slowly learned to collect older and older messages. Each improvement allowed scientists to look slightly farther into the darkness, which also meant looking slightly farther into the past. Eventually, something extraordinary became clear. There is a limit to how far we can see. Not because telescopes will someday become powerful enough to remove that limit, but because the universe itself has a history. Light has only had a certain amount of time to travel. Some regions are simply so distant that their messages have not yet reached us. You can imagine standing upon a quiet hill at dawn. The landscape slowly appears as sunlight spreads across it. Nearby fields become visible first. Distant forests emerge later. Faraway mountains wait longest of all. Not because they are hiding, simply because the light has not reached them yet. Our view of the universe works in a surprisingly similar way. There exists a great cosmic horizon, surrounding everything we can presently observe. Beyond that horizon, there may be countless more galaxies, perhaps endless ones. We simply have not yet received their light. Astronomers call everything whose light has had enough time to reach us the observable universe. The name sounds technical. Perhaps a gentler picture is easier to hold. Imagine opening an enormous library. Every book on its shelves has already arrived. Countless others are still being delivered. You cannot read books that have not yet reached the library, not because they do not exist, only because their journeys are still unfolding. The observable universe is much like that quiet library. Everything we know about the cosmos has arrived through light, patiently completing its journey. Every photograph captured by a telescope is, in a sense, already a memory. Every star is remembered through light. Every galaxy is remembered through light. Even the most distant objects ever observed are not showing us how they look today. They are gently sharing how they looked long ago, when their remarkable journeys first began. Perhaps that is why the night sky feels so timeless. It is not frozen. It is not motionless. It is quietly alive, with countless moments arriving together, each carrying its own chapter of the universe's story. And as we continue gathering these ancient messages, another gentle realization begins to appear. Eventually, those patient travelers do more than reveal where distant worlds are. They also reveal what those worlds are made of, how they move, and even how the universe itself has slowly changed across billions of years. As you continue drifting through this quiet journey, perhaps you can picture a single beam of morning sunlight entering a peaceful room. The light slips gently through the window without making a sound. For a brief moment, it hangs softly in the air. Tiny specks of dust seem to float like slow-moving stars, appearing and disappearing as they wander through the golden beam. Nothing dramatic is happening. And yet, within this simple scene, countless tiny conversations are quietly taking place. Until now, we have mostly followed light as it traveled through the great emptiness between stars. There, its journey was smooth and uninterrupted. But the universe is not made entirely of empty space. Eventually, every traveler meets something: a cloud, a drop of rain, a leaf, a window, a crystal, or perhaps your own eyes. Whenever light meets matter, something new begins. Imagine two old friends meeting after years apart. Sometimes they simply greet one another before continuing on their separate journeys. Sometimes they pause to share a story. Sometimes one changes the direction of the other's path. Light behaves in much the same gentle way. Each encounter is slightly different. The first and perhaps simplest meeting is reflection. Imagine standing beside a perfectly still lake early in the morning. The water is so calm that the mountains appear to exist twice, once above you and once below. The reflected image feels almost magical. Yet the lake is not creating a second mountain. It is simply sending light in a new direction. The tiny travelers that left the mountainside arrive at the water's surface, gently change direction, and continue onward until they reach your eyes. The lake quietly becomes part of the journey. A mirror behaves in a similar way. When you look into it, light first leaves your face. It reaches the smooth surface of the mirror. Then, almost gracefully, it changes direction before continuing toward your eyes. You are not looking through the mirror. You are receiving a carefully redirected story. Reflection quietly allows the world to take unexpected paths without changing the stories that light carries. Sometimes, however, light chooses a different response. Instead of turning away, it enters a new material. Imagine walking from a smooth stone path into fresh snow. You continue moving forward, but your pace naturally changes. Each step feels softer, slightly slower. Your direction may shift almost without noticing. Light experiences something surprisingly similar when it passes from empty space into water or glass. It continues its journey, but its path gently bends. Scientists call this bending refraction, but you can simply imagine light taking a graceful turn as it enters a different landscape. You have probably seen this many times. A drinking straw standing inside a glass of water appears slightly bent. A pebble resting beneath a clear stream seems closer than it truly is. Swimming pools often appear shallower than they really are. The water is not playing tricks. Light is simply choosing a new path before it reaches your eyes. The story arrives honestly. It has merely taken a different route. Glass offers another beautiful example. Imagine sunlight passing slowly through a crystal hanging beside a window. At first, the beam appears simple and white. Then, almost without warning, delicate bands of color begin spreading across the nearby wall. Soft reds, warm oranges, gentle yellows, cool greens, deep blues, quiet violets. It almost feels as though the crystal has created new colors from nothing. But the colors were already traveling together all along. White light is rather like a choir, singing in perfect harmony. Many voices join together until they sound like one. The crystal gently encourages each voice to take a slightly different path. One by one, the hidden colors quietly reveal themselves. This gentle separation creates the beauty of a rainbow. After rain has fallen, countless tiny droplets remain suspended in the air. Each drop becomes a tiny crystal of its own. Sunlight enters, changes direction, separates into its many colors, then quietly leaves again. Millions of tiny conversations together create one graceful arc stretching across the sky. Rainbows are not painted upon the clouds. They are quiet journeys, unfolding inside countless drops of water. There is another kind of conversation that light sometimes chooses. Instead of reflecting, instead of passing through, it simply stays. Imagine sunlight falling upon the leaf of a tree. Some of the light continues onward. Some quietly disappears inside the leaf itself. It has not been destroyed. Its energy has simply been welcomed into the tiny living structures hidden within the plant. There, the light begins helping to build sugars that nourish the tree. Long before forests filled the earth, sunlight had already begun teaching life how to gather its quiet gifts. Your own skin performs a similar conversation. So do your eyes. Every moment you look around the room, tiny travelers of light complete their journeys inside delicate cells at the back of your eyes. Those cells do not merely receive light. They transform its gentle arrival into tiny electrical signals that your brain quietly assembles into colors, shapes, faces, and memories. You never see light directly. You experience the beautiful story your mind creates from its arrival. Even the blue sky above us owes its beauty to one more gentle conversation. As sunlight enters Earth's atmosphere, it meets countless tiny molecules floating invisibly in the air. Most of the light continues peacefully toward the ground, but the shorter blue waves are gently scattered in many different directions. They wander across the sky far more eagerly than the longer red waves. Wherever you look overhead, some of those wandering blue travelers eventually find their way into your eyes. The sky is not filled with blue paint. It is filled with countless tiny journeys. Perhaps one of the quietest conversations happens far beneath the oceans. Thousands of long glass strands stretch across the seafloor, carrying nearly all of the world's internet traffic. Inside these delicate fibers, light continues traveling enormous distances. Its journey is not quite as swift as it is through empty space. The glass gently slows its progress, much as a traveler naturally walks more slowly through a peaceful forest than across an open meadow. Yet the light continues faithfully onward. Again and again, it reflects from the inner walls of the glass, bouncing so gently that it remains safely guided for hundreds or even thousands of kilometers. Every photograph you send, every message you receive, every quiet conversation shared across oceans, much of it travels as tiny pulses of light, patiently finding their way through transparent strands no wider than a human hair. It is remarkable to think that the same light illuminating a rainbow also carries voices across continents. The same quiet traveler paints sunsets, nourishes forests, fills the sky with blue, helps you recognize a familiar smile, and gently connects distant people who may never meet face to face. The universe, once again, reveals that many seemingly different experiences belong to one continuous story. And as scientists learn to read these countless conversations between light and matter, they discovered something even more extraordinary. Light was not only revealing where distant objects were, it was quietly revealing what they were made of, how they were moving, and how the universe itself had been changing since its earliest days. Imagine once again the quiet traveler we have followed throughout this journey. A single beam of light, it has crossed empty space with remarkable patience. It has carried messages from distant stars. It has wandered through clouds of dust, passed gently through glass, painted rainbows after storms, and quietly entered your eyes. Its journey has seemed wonderfully calm, wonderfully straight, and yet the universe still has another gentle surprise waiting. Imagine stretching a soft blanket across a wide bed. At first, its surface lies smooth and peaceful. Now place a small wooden ball in the center. The blanket sinks only slightly. Nothing dramatic happens. The fabric simply adjusts itself around the weight. Roll a tiny marble across the blanket. The marble no longer follows a perfectly straight path. Instead, it gently curves as it passes the small hollow. Not because an invisible hand reaches out to pull it. Not because the marble suddenly changes its mind. It simply follows the shape of the surface beneath it. This simple picture is not exactly how the universe works. No metaphor ever captures every detail, but it quietly points us toward one of Einstein's most beautiful ideas. Gravity is not merely an invisible force pulling objects toward one another. Instead, massive objects quietly reshape the very fabric through which everything travels. Earlier, we imagined space and time woven together like threads in a vast tapestry. Now we discover that this tapestry is not perfectly flat. Stars gently press upon it. Planets quietly reshape it. Entire galaxies create graceful valleys, so enormous that they influence journeys taking millions of years to complete. And light, faithful as always, simply follows the path that lies before it. It is rather like a peaceful hiker walking along an ancient mountain trail. The traveler does not invent the road. The landscape quietly guides each step. Light behaves in much the same way. It is not being pulled away from its journey. Its journey itself has become gently curved. Imagine our quiet traveler approaching an enormous galaxy drifting through the darkness. From far away, the beam seems destined to continue in a straight line. But as it draws nearer, the landscape of space itself begins to bend ever so gently. The light follows that graceful curve, then another, then another. By the time it reaches Earth, its path has become slightly different from the one it first began. To us, something extraordinary appears. A distant galaxy hiding behind the nearer one may suddenly become visible. Sometimes its image stretches into elegant arcs. Sometimes it appears twice. Occasionally, it forms a nearly perfect ring surrounding the nearer galaxy, like a delicate halo. Nothing has been duplicated. Nothing has been created. The universe is quietly acting as an enormous natural lens. Scientists call this beautiful phenomenon gravitational lensing. Perhaps tonight we can simply imagine gravity becoming a patient storyteller, gently redirecting beams of light so that hidden parts of the universe slowly come into view. It is one of nature's quiet acts of generosity. A galaxy that would otherwise remain unseen softly reveals itself, Because another galaxy happened to stand along the way. Light continues onward. Its journey is never hurried, never interrupted, only gently redirected. Our quiet traveler now drifts farther still. Ahead lies one of the most mysterious places in the universe, a black hole. The name itself can sound unsettling, yet perhaps we can think of it differently, not as a monster waiting in darkness, but as a place where space has folded inward more deeply than anywhere else we know. Imagine once more that stretched blanket. This time, instead of placing a small wooden ball upon it, imagine something so heavy that the fabric sinks into an impossibly deep valley. The sides become steeper, the curves become stronger. Every nearby path naturally bends inward. A beam of light, passing at a comfortable distance, simply follows the gentle curve before continuing its journey. Another beam drifting closer finds itself following an even sharper bend. Closer still, the paths become so dramatically curved that every possible direction continues inward. There comes a quiet boundary beyond which every future path leads deeper into the valley. Scientists call this boundary the event horizon. The name sounds technical. Perhaps a softer image is easier to hold. Imagine standing beside the crest of a waterfall. Leaves floating on the calm river above the falls can still drift away if the current carries them gently toward the shore. But once a leaf passes a certain point, every current leads only downstream. The leaf has not made a mistake. The river is simply carrying every possible path in one direction. The event horizon is rather like that quiet point of no return. Not a solid wall, not a magical surface, simply the place where the geometry of space itself allows no outward path to remain. Even there, light continues doing exactly what it has always done. It faithfully follows the road beneath its feet. The road itself has simply changed. Now imagine another beam beginning the opposite journey. It has climbed away from the deep gravity surrounding a massive star. It escapes successfully. It continues outward into the wider universe. Yet something subtle has happened along the way. It arrives carrying just a little less energy than when it began. Its color has shifted ever so slightly toward the red end of the spectrum. Not because it has become tired, not because it has aged, but because climbing away from deep gravity quietly changes the light's story. Scientists call this gravitational redshift. Perhaps we can simply picture a traveler climbing a long mountain path at sunrise. The traveler reaches the summit safely. The journey has been successful. Yet the climb has been long enough that the traveler now moves with a slightly gentler pace than before. The journey itself has quietly changed the traveler. Light carries that same quiet memory of where it has been. One of the most beautiful discoveries of recent years has revealed something else as well. Earlier, we learned that light never carries information faster than the universe's shared rhythm. Gravity quietly follows that same rule. If the sun were somehow to disappear, Earth would not know instantly. The light would continue arriving for a little while longer. The gentle pull of gravity would also continue for that same brief time. The universe allows neither light nor gravity to hurry ahead of the other. Both patiently carry their messages across space with the same faithful rhythm. It is another reminder that the universe seems less interested in speed than in harmony. Everything important waits its turn. Everything important arrives honestly. Our quiet traveler now leaves the great galaxy behind. It escapes the deep valleys of gravity. It crosses peaceful darkness once again. And after wandering across unimaginable distances, it eventually reaches a small blue world orbiting an ordinary yellow star. There, someone quietly looks up into the night sky. They see only a tiny point of light. Yet hidden within that single, gentle beam is the memory of curved space, ancient galaxies, invisible valleys, and one of the deepest ideas Einstein ever imagined. And perhaps, after following that remarkable journey, another quiet question begins to appear. If gravity cannot send its messages faster than light, could anything else in the universe ever do so? As our quiet traveler leaves the deep valleys surrounding distant galaxies and black holes, the universe feels peaceful once again. The beam continues exactly as it always has, patient, steady, faithful to the same invisible rhythm we have followed since the beginning of our journey. Yet another question quietly rises, one that has captured human imagination for generations. If light moves with such remarkable speed, could anything ever move even faster? It is the kind of question children naturally ask. It is also the kind of question that many scientists have spent lifetimes exploring. Not because they wish to break the universe's rules, but because curiosity has always gently wondered whether there might be another path hidden just beyond the horizon. At first glance, nature occasionally seems to whisper that perhaps there is. Imagine watching a quiet swimming pool late in the afternoon. A child runs along the edge and dives smoothly into the water. Ripples spread outward. Tiny bubbles drift upward. Everything follows a familiar rhythm. Now imagine something moving through the water so quickly that it creates a faint blue glow. This beautiful phenomenon is called Cherenkov radiation. The name may sound unfamiliar, but the image itself is wonderfully gentle. It is often described as the underwater cousin of a sonic boom. When an airplane flies faster than sound can travel through air, it creates a sudden wave that many people recognize as a powerful boom. Something surprisingly similar can happen with light inside certain materials. Here is the important detail. The light itself is not being outrun through empty space. Instead, light naturally moves a little more slowly inside materials such as water or glass than it does through the quiet emptiness between the stars. Imagine once again our peaceful traveler walking across different landscapes. Across an open meadow, the journey is easy. Through a quiet forest, every step becomes a little more careful. The traveler has not changed. The landscape has. Particles moving through water can sometimes travel faster than light moves inside the water. They cannot, however, outrun light moving through empty space. The universe quietly keeps its deeper promise. The blue glow is not evidence that nature's greatest rhythm has been broken. It is simply another beautiful conversation between light and matter. Another gentle reminder that appearances can sometimes surprise us. Then there is another mystery, one that has puzzled scientists for nearly a century. Imagine placing two beautifully crafted musical boxes side by side. You gently wind them both. For a while they remain together. Then you carry one box to the opposite side of the world, perhaps even farther. Imagine separating them by unimaginable distances. Now, somehow, changing one seems mysteriously connected with the other. This strange relationship resembles one of the most fascinating discoveries in quantum physics. Scientists call it quantum entanglement. The name sounds complicated. Perhaps we can simply imagine two tiny dancers who once learned the same graceful choreography. Even after moving far apart, they continue revealing a quiet connection that seems almost impossible to explain using ordinary intuition. When physicists first discovered this remarkable behavior, many wondered whether it might finally allow messages to travel faster than light. It was an exciting possibility. If two distant particles remained connected, perhaps one could instantly send information to the other. Yet nature, once again, quietly chose a gentler path. The connection is real, The mystery is real, but no usable message travels faster than light. You cannot arrange those tiny dancers to secretly carry tomorrow's news across the galaxy. You cannot use entanglement to telephone another star instantly. The universe preserves the connection. It also preserves its quiet order, 'cause still comes before effect. Information still follows the same faithful rhythm we have encountered again and again. Every time scientists believed they had discovered an exception, the universe gently invited them to look a little more carefully. There is another idea that occasionally appears in conversations about faster-than-light travel. It comes not from observation, but from mathematics. Some equations quietly allow the possibility of hypothetical particles that would always move faster than light. Physicists gave these imagined travelers a name many years ago. They called them tachyons. No one has ever observed such particles. No telescope has photographed them. No laboratory has measured them. They remain interesting mathematical possibilities rather than established features of nature. They remind us that mathematics is wonderfully creative. Sometimes it describes the real universe. Sometimes it describes possibilities that reality quietly chooses not to follow. Science is comfortable with both. It welcomes imagination. It simply asks that imagination patiently wait for evidence. Human imagination has wandered even farther. Writers, filmmakers, and scientists alike have imagined remarkable ways of crossing enormous cosmic distances. Some ideas suggest gently bending space itself instead of moving through it. Others imagine distant regions becoming connected through hidden tunnels in the fabric of the universe. These ideas are often called warp drives and wormholes. They are beautiful ideas, elegant ideas, ideas that encourage us to think beyond familiar horizons. At present, however, they remain speculative. No spacecraft has traveled this way. No experiment has shown us such journeys unfolding in reality. That does not make them unworthy of wonder. It simply reminds us that science walks carefully. It prefers quiet evidence to dramatic certainty. Perhaps that is one of its greatest strengths. The universe has surprised us many times before. It may surprise us again. Yet every genuine discovery begins not with excitement, but with patient observation. As we have wandered through these possibilities, something beautiful has quietly emerged. Every apparent exception eventually teaches us a deeper lesson. The blue glow beneath water reminds us that materials can gently change light's journey without breaking the universe's deeper rhythm. Quantum entanglement reminds us that nature can be profoundly mysterious while still respecting the quiet order of cause and effect. Mathematical ideas remind us that imagination often reaches farther than observation, and speculative journeys remind us that asking bold questions is part of what makes science so deeply human. Perhaps the universe is not protecting a speed limit because it wishes to prevent exploration. Perhaps it is quietly preserving a language that every star, every galaxy, every atom, and every beam of light already understands. A language built upon consistency, patience, harmony. The more carefully we listen, the more that invisible rhythm seems to appear everywhere. It is woven into gravity. It is woven into light. It is woven into time itself. And perhaps that rhythm is not simply the speed at which light travels. Perhaps it is something even deeper. Perhaps it is one of the quiet threads from which reality itself is woven. Imagine holding two objects in your hands. In one hand rests a ruler, in the other a small clock. One measures distance, the other measures time. Since childhood, these have seemed like completely different ideas. You use a ruler to measure the length of a table. You use a clock to measure how long it takes to read a book. One belongs to space, the other belongs to time. They appear to have almost nothing in common. And yet, as our journey has slowly unfolded, the universe has been quietly suggesting something very different. Again and again, we have watched space and time move together. When motion changed, time adjusted. When gravity curved the universe, both space and time curved together. When light traveled across the cosmos, its steady rhythm quietly linked every journey. Perhaps the ruler and the clock have never truly been strangers. Perhaps they have always been two ways of describing the same deeper reality. Imagine listening to a beautiful piece of music. One person pays attention to the melody. Another notices only the rhythm. A third listens for the quiet harmony beneath them both. Each person describes something different, yet all are listening to the same song. Space and time feel very much like that. They are different ways of noticing one continuous pattern. The speed of light quietly becomes the bridge connecting them. Whenever light travels, it links distance with duration. A certain amount of distance naturally belongs to a certain amount of time. The relationship is so faithful that modern science quietly builds many of its measurements upon it. Earlier, we discovered that humanity eventually chose to define distance using light itself. It was an extraordinary change in perspective. For thousands of years, people measured light using rulers. Now rulers quietly depend upon light. It is almost as though the traveler became the guide. The messenger became the language. Imagine learning two different languages as a child. Perhaps one counts using familiar words. Another counts using completely different sounds. At first, they seem unrelated. Eventually, you realize they are describing the same numbers. Only the language has changed. Something similar quietly happens throughout modern physics. Sometimes scientists measure distances. Sometimes they measure time. Sometimes they gently convert one into the other, using the universe's shared rhythm. It is rather like translating one language into another. Nothing is lost. The same story simply appears in a different form. This idea becomes even more beautiful when we remember one of Einstein's most famous discoveries. Long before our journey tonight began, you may have heard that energy and matter are deeply connected. The relationship is often written as one of the most famous expressions in all of science. Tonight there is no need to picture symbols or equations. Instead, imagine a quiet conversation between two old friends. One friend is matter, the mountains, the oceans, the trees, your own body. The other friend is energy, warmth from the sun, the glow of a candle, the light of distant stars. For centuries they seemed completely different. One appeared solid, the other seemed almost invisible. Einstein gently revealed that they are not strangers at all. Under the right conditions, matter and energy can quietly transform into one another. Different expressions, one deeper reality. And hidden within that relationship is the same faithful constant we have been following all evening. Not because it belongs only to light, but because it belongs to the structure of the universe itself. It quietly tells nature how these different ideas fit together. Perhaps another image makes this feel even softer. Imagine a skilled translator sitting between two friends who speak different languages. Neither friend fully understands the other alone. Yet the translator quietly allows each conversation to flow naturally. No attention is drawn to the translation itself. It simply makes understanding possible. The universe's quiet constant behaves in much the same way. It allows distance and time to speak to one another. It allows matter and energy to speak to one another. It quietly reveals that many ideas we once believed to be separate are, in truth, parts of one larger conversation. As physics continued to grow, scientists noticed something curious. In many calculations, this constant appeared so naturally, so frequently, that they sometimes chose a wonderfully elegant shortcut. Rather than writing it over and over again, they simply allowed it to become the quiet background of the calculation itself. It was rather like a musician no longer counting every individual beat, because the rhythm had become part of their breathing. Or a sailor no longer thinking consciously about the motion of the sea after many years upon the water. The constant did not disappear. It became so deeply understood that it quietly blended into the background. This choice does not change nature. It simply reminds us that some ideas become so fundamental, they no longer need constant introduction. Like gravity gently holding your feet to the earth. Like breathing while you sleep. Like the steady rhythm of your heartbeat, some truths become so familiar that they quietly support everything else. Perhaps that is the greatest lesson this remarkable constant offers. It is not simply a large number. It is not merely the speed of sunlight crossing space. It is one of the deepest patterns nature has ever revealed. A quiet agreement shared by stars and galaxies, by atoms and black holes, by clocks and rulers, by light itself. The more carefully we have listened throughout this journey, the less this remarkable constant has seemed like a rule imposed upon the universe. Instead, it has begun to feel like part of the universe's own quiet grammar. Every language has rules that allow words to become meaningful sentences. Without them, communication slowly falls apart. Perhaps the cosmos possesses a grammar of its own. A gentle structure that allows space, time, gravity, energy, matter, and light to speak one beautifully consistent language. And perhaps that same language has been quietly surrounding you all along. Every morning as sunlight enters your room, every evening as distant stars appear overhead, every moment your eyes gently receive another ancient beam that has crossed the universe simply to arrive here, tonight. As beautiful as these ideas may be, they are not confined to distant galaxies or quiet laboratories. They are already woven into the ordinary rhythm of your own everyday life, often in ways so familiar that they pass unnoticed. After wandering among distant galaxies, following ancient beams of light across billions of years, it may be comforting to come home again, not because the universe has become any smaller, but because you begin to notice that the same quiet ideas have been living beside you all along. Imagine tomorrow morning. The room is still. Perhaps the curtains are only slightly open. Outside, the first birds have already begun greeting the day. Without asking permission, a gentle beam of sunlight slips through the window and slowly brightens the room. Before you even move, countless tiny travelers have already reached your eyes. The journey that began at the surface of the sun a little while ago quietly ends inside delicate cells waiting at the back of your eyes. Those tiny cells perform one of nature's most beautiful acts. They do not keep the light. Instead, they quietly translate it. The travelers become tiny electrical messages. Those messages flow gently through your nervous system. Your brain patiently gathers them together. Color appears, shapes emerge, depth quietly forms. A familiar room returns. It happens so effortlessly that most mornings we never notice the miracle taking place. We simply open our eyes. Yet hidden within that ordinary moment is a conversation between sunlight, living cells, and the quiet laws of the universe. You are not merely looking at the world is gently arriving to meet you. Perhaps, after getting out of bed, you reach for your phone. The screen quietly wakes. Within moments, Messages appear from people living many streets away, perhaps even on another continent. The journey of those messages is remarkably peaceful. Some travel through invisible radio waves, drifting between your phone and a nearby antenna. Others continue through long strands of glass, stretching beneath cities, forests, mountains, and even the oceans. Inside those transparent threads, tiny pulses of light begin another patient journey. Earlier, we imagined light walking through different landscapes. Inside these glass pathways, the traveler moves a little more slowly than it does through empty space. Yet the journey remains astonishingly swift. Again and again, the light gently reflects from the inner walls of the glass, almost like a quiet traveler following the curves of a long mountain valley without ever leaving the path. Thousands of kilometers pass. Entire oceans quietly disappear beneath the journey. A conversation that began in one country softly arrives in another. Most of us simply think of this as the internet. Rarely do we picture countless tiny flashes of light patiently carrying nearly every photograph, every video call, every article, and every kind message shared between people. The world's conversations often travel not as voices, but as gentle pulses of light. Later, perhaps you leave home and begin driving toward work, school, or somewhere peaceful. Your phone quietly suggests the quickest route. It seems almost magical. A tiny blue dot knows exactly where you are. Yet far above Earth, satellites continue circling the planet with extraordinary patience. Earlier in our journey, we discovered that the clocks aboard those satellites do not experience time in exactly the same way as clocks here on Earth. Every day, gentle corrections quietly keep those clocks synchronized. Without them, the blue dot on your screen would slowly wander away from your true location. Roads would become uncertain. Ships would drift from their intended paths. Airplanes would lose the quiet precision upon which modern travel depends. Every successful journey guided by satellite navigation carries a quiet thank you to Einstein's understanding of light, space, and time. Most travelers never notice. The universe does not mind. Its quiet work continues anyway. Throughout the day, invisible waves quietly surround you. Some carry music to your car. Some allow wireless headphones to play your favorite songs. Some help your computer speak to the nearby router without a single visible wire. Others quietly warm your lunch inside a microwave oven. Although these technologies seem wonderfully different, they all belong to the same great family we met much earlier, the family of light. Some members of that family are visible. Others remain forever beyond human sight. Yet they all share the same quiet ancestry, the same invisible dance of electricity and magnetism, the same faithful rhythm carried across the universe. It is rather like one enormous family gathering, where every relative has chosen a different profession. One becomes a musician, another a teacher, another a gardener. They appear wonderfully different, yet deep down, they all belong to the same home. The invisible waves surrounding your phone, your radio, your wireless headphones, and your kitchen quietly belong to the same family as the sunlight warming your skin each morning. Perhaps later that afternoon, somewhere nearby, a doctor carefully prepares for delicate surgery. Instead of holding an ordinary knife, the surgeon guides an extraordinarily focused beam of light. It cuts with astonishing precision. It seals tiny blood vessels. It reaches places that would otherwise be difficult to access. The light does not become a doctor. It simply offers another gentle way of helping skilled hands care for another human being. Elsewhere in the same hospital, other forms of light quietly reveal broken bones, examine delicate tissues, or help scientists observe cells too small for the human eye alone. Again and again, light becomes not merely something we see, but something that quietly helps us understand. As evening approaches, the sun slowly lowers toward the horizon. Its light passes through more of Earth's atmosphere than it did at midday. Many of the blue travelers that once wandered freely across the sky are now scattered away before reaching your eyes. The longer red and orange waves continue their patient journey. The sky glows with warm colors. Another ordinary sunset quietly becomes a lesson in physics, though it asks for no applause. You simply watch. Perhaps you smile. Perhaps you do not think about science at all. That is perfectly enough. Even after darkness settles across the landscape, the journey continues. High on distant hills, enormous radio telescopes quietly listen to invisible waves arriving from galaxies millions of light-years away. Far above Earth's atmosphere, space telescopes patiently gather ancient beams that began traveling before our own planet existed. Meanwhile, beside your bed, a small wireless signal may still be carrying tomorrow's weather forecast to your phone. The scales are unimaginably different, yet the quiet laws remain exactly the same. That may be the most comforting realization of all. The universe does not invent new rules for distant galaxies and different rules for your living room. The same invisible rhythm guides both. The same faithful traveler that bends around galaxies also carries a message from someone you love. The same gentle laws that shape the earliest light in the universe also help you find your way home after sunset. Perhaps this is why science can feel unexpectedly peaceful. The farther we wander into the cosmos, the more deeply we begin to understand the ordinary moments waiting quietly around us. And if light can carry messages across oceans, through hospitals, into your eyes, and between distant galaxies, perhaps it has also been carrying something even greater since the beginning of the universe itself. Not merely information, but the entire story of how the cosmos slowly learned to become the home we know today. Imagine that our quiet traveler has been wandering for longer than anyone could possibly remember, long before oceans covered the earth, long before mountains rose toward the sky, long before the first leaf unfolded beneath the sun. Even before the first star ever began to shine, there was already light. Not the familiar sunlight warming your face each morning, not the gentle glow of distant galaxies. Something far older, something that has been traveling almost since the universe itself first became transparent. Earlier in our journey, we discovered that looking farther into space also means looking farther into the past. Now we continue that gentle journey all the way back to the earliest chapter that light can still tell. Imagine standing inside a great cathedral just after dawn. At first, the building is almost completely dark. Then, very slowly, the first rays of sunlight begin entering through the stained glass windows. Little by little, hidden colors awaken, stone pillars emerge, painted ceilings quietly reveal themselves. The room has not suddenly appeared, it was always there. The light simply needed time to fill it. The early universe experienced something surprisingly similar. In its earliest moments, everything was so unimaginably hot and crowded that light could not travel freely. Every tiny traveler was constantly interrupted. Each attempted journey lasted only the briefest instant before another encounter changed its direction. The universe was not dark because light did not exist. It was bright beyond imagination. So bright, in fact, that light could not yet escape. Then, as the universe slowly expanded, it also became cooler, gentler, quieter. Eventually, there came a peaceful moment when light could finally begin traveling freely across space. Some of those ancient travelers are still moving today. They have crossed almost the entire observable universe. After billions of years, a tiny fraction of them quietly arrive at Earth. Scientists call this ancient glow the cosmic microwave background. The name sounds technical. Perhaps you can simply imagine it as the oldest photograph the universe has ever shared. Not a photograph taken with a camera, a photograph carried by light itself. Every direction you look into the sky contains this gentle, ancient whisper. It is astonishing to realize that the oldest light we can observe has been patiently traveling for almost the entire history of the cosmos. Like an old letter finally reaching your hands after an unimaginably long journey. As the universe continued expanding, another quiet transformation unfolded. Tiny clouds of matter slowly gathered together. Gravity patiently drew them inward. The first stars quietly ignited, then galaxies, then clusters of galaxies. The darkness slowly filled with islands of light. Our traveler continued moving among them all, sometimes leaving newborn stars, sometimes drifting through enormous galaxies, sometimes crossing vast regions of peaceful emptiness, where almost nothing interrupted the journey. Yet the universe itself was still quietly changing. Imagine drawing small dots across the surface of a balloon. Now gently begin inflating it. Every dot slowly moves farther away from every other dot. Not because the dots are crawling across the rubber. The surface itself is expanding. This familiar image is not perfect, but it gently hints at one of the most beautiful discoveries in astronomy. Galaxies are not simply flying through space. Space itself has been slowly stretching for billions of years. As our quiet traveler crosses this gently expanding universe, its own gentle waves become stretched as well. The light slowly shifts toward the red end of the spectrum. Scientists call this redshift. Tonight, perhaps it is enough simply to imagine a familiar melody gradually becoming lower and softer as it drifts across an enormous valley. The song remains the same, only its rhythm has gently changed during the journey. That quiet shift tells astronomers something remarkable. The greater the redshift, the farther the light has usually traveled, and the farther it has traveled, the earlier in cosmic history it began. Distance quietly becomes time once again. Light continues, proving itself to be one of the greatest storytellers the universe has ever known. Yet its stories do not end there. Imagine holding a beautiful crystal up to sunlight. The white beam gently separates into many colors. Earlier, we admired that quiet rainbow simply for its beauty. Astronomers learn to admire something even deeper. Every star produces its own delicate pattern of colors, almost like a fingerprint. No two stars tell exactly the same story. Some patterns quietly reveal hydrogen, others whisper of helium, oxygen, carbon, or iron. Some reveal stars growing older, others reveal stars newly born. Scientists are not reading words. They are patiently learning to read the colorful fingerprints carried by light. Without ever touching a distant star, they can begin to understand what it is made of, how hot it is, how quickly it is moving, even whether planets may be quietly circling around it. Light has become both messenger and translator. Its journeys carry not only brightness, but understanding. Eventually, one small star formed near the edge of an ordinary galaxy. Around that star, a quiet blue planet slowly cooled. Rain fell, oceans gathered, life appeared. Once again, light patiently found a new role. Tiny living cells learned to capture sunlight. They quietly transformed its energy into nourishment. Leaves unfolded. Forests slowly spread. Every tree became another gentle conversation between light and life. Millions of years later, eyes evolved. Creatures began recognizing sunrise. They learned to distinguish day from night. The rhythm of light quietly became the rhythm of sleep, waking, migration, flowering, and seasons. Even tonight, as you listen, tiny groups of cells within your own brain continue paying quiet attention to light. Not because they are curious, but because they help guide the gentle cycle of waking and sleeping that has accompanied humanity since the very beginning, long before clocks measured hours. Light was already teaching life how to keep time. Perhaps that is one of the most beautiful thoughts in our entire journey. Long before human beings learned to ask questions, light had already begun answering them. Long before the first telescope looked toward the heavens, light had already crossed the darkness. Long before life learned to open its eyes, light was already traveling, patiently, faithfully, silently carrying the history of the universe toward every future generation that might one day look up and wonder where it had come from. And now, after following that remarkable traveler across nearly the entire history of the cosmos, there remains only one quiet step left in our journey: to return home, to the gentle beam of sunlight that first entered a quiet room, and to discover that, hidden within its ordinary warmth, the entire universe has been softly waiting all along. Imagine that it is morning once again. Not the beginning of this journey, the beginning of another ordinary day. The room is quiet. Perhaps the curtains are still partly closed. Perhaps the world outside has only just begun to wake. Almost without noticing, a gentle beam of sunlight slips through the window and quietly settles upon the floor. Nothing about that light appears unusual. It asks for no attention. It makes no sound. It simply arrives, just as it has every morning for countless generations. When our journey first began, this beam of light seemed wonderfully familiar, almost too familiar to notice. It was simply part of another sunrise, another ordinary day. But now, after wandering together across the universe, perhaps it feels just a little different. Not because the light has changed, because you have. You now know that hidden inside this quiet beam is a story stretching across almost everything we have explored together. It carries the same gentle rhythm that first escaped into the young universe billions of years ago. It follows the same invisible rules that quietly guide distant galaxies. It obeys the same patient geometry that bends around stars and black holes. It travels with the same faithful consistency that helps satellites guide people safely home. The beam entering your room this morning belongs to exactly the same universe as the oldest light still drifting across the cosmos. There are not two different sets of rules, one for everyday life, another for distant space. There has only ever been one quiet story. Perhaps that is one of the most comforting discoveries science can offer. The universe is not a collection of disconnected pieces. It is one great conversation. Every star contributes a sentence. Every galaxy adds another chapter. Every beam of light quietly carries another message across the darkness. And somehow, after billions of years, some of those messages gently arrive here, in this room, on this small planet, at this very moment. Earlier, we wondered why light has a speed limit. It seemed like a simple question, perhaps even a small one. Now we can see that it quietly opened the door to something far larger. It led us toward electricity and magnetism dancing together through empty space. It introduced us to Einstein's extraordinary vision of space and time. It revealed why clocks can quietly disagree while both remain correct. It showed us why gravity gently bends the paths of light. It explained why we look into the past every time we lift our eyes toward the stars. It even returned us home again, showing how the same invisible rhythm quietly supports communication, navigation, medicine, and the simple gift of seeing the faces of the people we love. A single question became many peaceful answers, and every answer quietly pointed toward another. There is something deeply reassuring about that. Science is often imagined as a search for certainty, yet perhaps its quieter purpose is something gentler: to notice patterns, to listen carefully, to become a little more patient with mysteries that are not yet ready to reveal themselves. Even now, after everything we have explored, some of the most beautiful questions remain unanswered. Why does the universe possess this particular rhythm and not another? Could it have been slightly different? If it were, would stars still shine? Would galaxies still form? Would life still have appeared beneath an ordinary yellow star? No one knows. Perhaps somewhere within the deepest structure of reality, there exists an explanation still waiting to be discovered. Or perhaps the universe simply is the way it is, inviting curiosity without ever promising complete understanding. Scientists continue searching. They build larger telescopes, more sensitive instruments, more elegant theories. Some hope that one day our understanding of the smallest particles and the gentle curves of gravity will quietly become one unified picture. Perhaps there remains another layer beneath everything we currently know. Perhaps there does not. The universe has surprised humanity before. It may quietly surprise us again, and if that day comes, it will almost certainly begin the same way so many discoveries have always begun, with someone noticing something small, asking one gentle question, and patiently listening for the answer. Perhaps that is the quiet lesson hidden beneath every scientific discovery. The universe does not hurry. The stars are in no rush to burn. Galaxies drift without urgency. Light itself has crossed billions of years without ever appearing impatient. There is something deeply peaceful about belonging to a universe that understands patience so completely. As you rest here now, perhaps your breathing has become slower. Perhaps the room feels softer than it did an hour ago. Outside, light continues its endless journeys. Some beams are only now leaving distant stars. Others are quietly arriving at planets whose names we may never know. Some are crossing empty space between galaxies. Others are warming leaves that gently turn sunlight into life. Still others are slipping through someone's window, just as they once slipped through yours at the beginning of our story. The journeys continue, whether we notice them or not, whether we understand every detail or not. The universe quietly carries on, and perhaps that is enough. You began tonight by watching a quiet beam of sunlight enter a peaceful room. Now you know that within that gentle light lives the same invisible rhythm that guides galaxies, bends around black holes, keeps satellites in quiet agreement, paints rainbows after gentle rain, shapes every sunrise, and softly connects you to stars whose journeys began billions of years before you were born. The light has never stopped telling that story. It has simply been waiting for someone to listen. And now there is nothing more you need to do, nothing more you need to solve. The universe will continue unfolding in its own quiet rhythm. The stars will continue shining. Light will continue traveling. Morning will gently become evening. Evening will quietly become morning once again. You are safe. You are warm. You are part of this remarkable story, just as every beam of light has always been. And while you drift peacefully towards sleep, the universe will keep carrying its oldest messages through the darkness, one gentle journey at a time.